but it's important. Okay, it's important, and I want to start with that, why it's important. Okay, quick Google search. We've done it before. For Manitoba High School graduation requirements, look what Google says. To obtain a Manitoba High School diploma, students must acquire a minimum of 30 credits from a combination of compulsory and optional courses. If I keep going forward from here, this is actually the Department of Education from the Government of Manitoba. And if I go forward from here, this is their little one-page thing that shows you what you need to graduate. And here you can see that you need 17 compulsory credits. 5 in grade 9, 5 in grade 10, 4 in grade 11, and only 3 in grade 12. Okay? Why do I hear music? It's over there. Torres, is that your music? There are a bunch of grade 12s in this building right now who are absolutely panicked to make sure they have all of these. But it's not just 17. You need 30 credits to graduate. So 17 plus 13, which is optional. A lot of you are having no trouble with optional credits, right? You might be getting a hairstyling credit or a welding credit or a, whatever, drama credit, good example, right? Whatever. Those are probably going to be easier for you because you get to choose them, right? So you're going to choose ones that you feel you're good at or that you like, and you're not going to choose ones that you're not good at or you don't like. But there's nothing you can do about these compulsory credits. And to refocus, we are specifically talking about this one. This is your math zone. You'll notice you need a math credit in all 4 grades, okay? Including, I don't know if I can, you probably can't see it, that says Math 10F. That's the grade 9 math course. You can't avoid it. You can't. You also can't avoid the grade 10 math course, but if I zoom in on the grade 10, you'll notice that's the year you can start making some choices. So in grade 10, yes, we can make some choices here. So in grade 10, you got a choice. I can take Essentials Math, or this Essentials Math, or Intro to Pre-Calculus Math. Then as I move into grade 11, I've got similar choices, and in grade 12, I've got similar choices. And I get more choices as I move, right? This is a reality, okay? It's not that way in all your subject areas, right? So for example, in history/social studies, you don't have choices. You take the grade 9 social studies, then the grade 10 geography, and then the grade 11 history. There is no choices. At one time when I first started teaching, there was 2 histories to choose from. They don't have that anymore. They just have the one. Science has only 2 choices. Grade 9 science, grade 10. By the way, did you know that's it? After grade 10, you don't have to take any more science to graduate. Yes? Yeah. It was just called History 30G and History 30F. One had more essays in it, and one had more projects in it. So that's the reality. Now, here's more reality. I've shown you this before. If I go to the grade 9 math curriculum, what you guys need to be ready to do to go beyond just the grade math that you're in now, and again, I'm going to Manitoba Education and go forward from there, I get to this document. This is a teacher document. But for example, in the stuff I'm showing you right now, this is actually, I don't know if you guys can see, this is not a grade 8 document I opened, or grade 9. This is a grade 8 document I just opened. In the grade 8 math, it's expected, for example, in algebra, that you can do these. Now, I don't expect you to totally understand that because it's written in teacher talk. But these are the kind of algebra questions you can expect in grade 8. So when you go into grade 9, you can expect that they're going to expand on these. So I thought I'd show you something. This is just this January's math exam that just went down a few months ago. You need to pass this exam to get the grade 9 credit. You will need to pass it to get the grade 9 credit the next time you write this exam. Here is a question from that exam. This is right off the exam. Here's the question. Solve for x in this particular problem. And these are 3 options that you choose from. Okay? This assumes that you knew everything that you needed to know from the grade 8 curriculum and some stuff from grade 9. But by the end of the period today, I'm hoping that you guys can actually do this question, or at least see how it could be done, to actually understand how to do this question, which is right off of this year's exam. Okay? If you don't know how to do this type of question, this is all the more reason you should be kind of paying attention and getting ready so that I can help you. Because we started with this. We started with algebra that looked like this. Whoops, sorry, hang on. Let me try it this way. Okay? That's where we went in part 1. Then we went to here. Okay? That's what we did in part 2. We also did different versions of these, right? We had like x minus 3 equals 5. And x over 2 equals 5. This is using your basic math functions, right? Using addition, using subtraction, using multiplication, using division. But you also know that in algebra, these two are not written that way anymore. Algebra teachers aren't going to write them that way, and you need to be ready to adapt to that. You're going to see stuff like this, where they use 4x means 4 times x. You're going to see stuff like this, which means x over 2 means x divided by 2. These symbols are now banned. Well, they're not really banned, but they're rarely used by algebra teachers because they can be confusing when using algebra. But what we've been developing is a method to work through these. A method, a fail-safe method that'll get you guys through it. And the method focuses on a couple key words that you guys have done creative projects on. One of them was balance. The other one was opposite. And you're going to see those 2 words come up again today. That it's all about balancing stuff, and it's all about doing the opposite. But as the questions get harder, I have to add in a few more key things. So today, we're going to talk about how this factors into it. Brackets. We've talked about brackets before, but how does this work in algebra? How do brackets kind of come into play? And when solving these things, okay, we're going to need to do this sometimes in multiple steps. And some of you have seen already this was a problem. This is why maybe you weren't successful in the grade 9 math, is you thought you could do this all in one step. Just like right now, some of you think that if you talk in my class that this is magically going to change your math mark. And I'm going to be watching some of you 2 years from now, 3 years from now, in Alt-Ed, with math booklets, not getting math credits, and you had an opportunity, you had a course in front of you where you had a teacher, teachers, multiple teachers, looking to help you to get through this stuff, and you couldn't be bothered. Your phone was more important then. The phone that you won't be able to pay for in a couple years because you don't have a job, because you don't have a diploma, because you didn't get math. Now, I might be wrong. I could very well be predicting the future incorrectly. I hope so. But I also know that as a teacher who's taught for 16 years, I've run into students who have told me their regret for not taking help. Now, I'm not saying these students wanted to be like math professors or anything like that, but they often regretted the fact that they didn't try harder at that time. And this is honestly a factor of immaturity, I think. All right. That's my pitch. That's my attempt to get you guys to lock in to what I'm about to show you in today's presentation on Algebra Part 3, Algebraic Forms Part 3. Okie dokie. Let's get started. So last time when we looked at algebra, we looked at this difference between multiplication and division and how important that was in algebra. But it's really about opposites, or sometimes called the inverse. That the opposite of positive is negative and vice versa. The opposite of addition, subtraction, multiplication, division. And our method now involves 5 steps. Today we're going to add yet another step to this method, but it's the same method. We just keep sort of changing it a little bit. Do any arithmetic, do the opposite, balance it by doing whatever you did to one side, do to the other, Make sure the variable is all alone before you're done, or isolated, and then check it. That's your steps, okay? But in some cases, this is going to require more than one step, okay? So we have this pretty good method, but as things get harder, the steps are going to increase. You're going to have to write more stuff down to get to the solution, okay? But the good news is, our method isn't going to change. It's just going to add a little step in there that causes you to possibly repeat a step. This is like you see on shampoo bottles. Have any of you ever read a shampoo bottle? The instructions, do you know what it says on a shampoo bottle? It says lather, rinse, repeat. Why do they do that? Why do they want you to wash your hair twice? Any idea why a shampoo company would do that? Why? Yeah, that's right. So you use up more shampoo and then go buy more shampoo. Do you really need to? And if you just kept following that instruction, if you were a complete moron, you'd be washing your hair right now because you would be constantly repeating yourself and you'd never get out of the shower, right? But that's something that could be factored in here, is we need to repeat a step. Okay, so here's an example. 3x plus 4 equals 13. Okay? So this is an example of one that's going to require more than one step. So step 1, can we do any arithmetic first? Well, on this side of the equal sign, I can't do anything with 13. There's no arithmetic there. On this side, I can't do any arithmetic because there's a variable there. I can't add 3x and 4. I can't add them together. So I've done step 1. Step 2, I'm going to remove values on the same side as my variable, but I'm going to start with any values that aren't attached to the variable. So the 3 and the x seem to be attached together. So I'm going to start by getting rid of the 4. And I do the opposite. We've already done that before. I do the opposite by subtracting 4. But when I do the opposite, I also keep balance by doing the same thing on one side and on the other. So if I subtract 4 from this side, I subtract 4 from this side, and I get 9. Now I'm here. So that was one step. To move from here to here was one step. Now, I need to go back and do it again. I need to repeat the process. To get rid of the 3, this means 3 times x. I do the opposite, which is opposite of multiplication, division. So I divide both sides by 3, and I'm left with 3. Okay? Because 9 divided by 3 is 3. But this required 2 steps. Step 1, moving to 3x equals 9, and then step 2, moving to x equals 3. Multiple steps because in my method, I had to repeat a piece of this. So I'm adding in kind of some new sort of steps in here in terms of repeating it. And I can check it, and it checks, right? 3 times 3 is 9. 9 plus 4 is 13. 13 equals 13. It checks out. Okay, so what do we know about this process now? We had to make some modification to our steps. So for example, when I say remove values on the same side of the variable, not connected to the variable, what I mean is this is connected. 3 and x are connected, right? So I should start with getting rid of that first because it's easier. If I divide by 3 first, it's not going to make my life easier. So if I get rid of the 4 first, that's easier, okay? It makes it go away by doing the opposite, okay? And as I've already said, there's a step in here that might require us to repeat this. Okay, let's go through a couple more examples. Here's one. X over 5 minus 2 equals 3. Now here you can see your guess and check method isn't necessarily going to work for you anymore. So now you want to go to the method. Step 1, any arithmetic I can do? No. Step 2, remove values on the same side as the variable, starting with ones unattached. So I'll remove the 2 by, oh, I'm sorry, that should say plus 2. Plus 2. Oh, I think I screwed up this one. So then it's there. And then I do the opposite again, which is to multiply by 5, which is the opposite of dividing by 5. Okay? And it would check out. Okay. So we've made a modification. Okay? Basically, we want the variable all alone. This is now the next piece that's super important to what we need to remember. Balance, opposite, yes, brackets is important. But there's one other thing we need to do. We need the variable alone. That's how we know we solved it. And in doing that, that might cause us to have to go back and do this again and again and again. So multiple steps in doing it alone might mean that we have to repeat some of this. Keep doing the balance, keep doing the opposite. Until it's alone, keep repeating. And somehow this is going to factor into this. Where do brackets fit? Well, I'm going to tell you, the brackets actually fit up here. That's going to be one of the first things we do. Okay? All right. So this is, by the way, why the method is called the inverse, do the opposite, operations, for math operations, method, step by step. This is what you're going to hear in grade 9 math class. You're going to hear teachers say inverse operations method. You might have been intimidated by that. You may have thought, well, what does that mean? Don't overthink it. It basically just means, as we were just saying, that you're doing the opposite and keeping balance. That's the whole inverse. Okay, and operations just means you're doing arithmetic. Okay, to get it all by itself alone, and then you have it solved. So you don't want to overthink that. Balance is important, opposite is important. All right, but now let's make it harder. It gets harder by adding in brackets into this. Okay? Now, we've talked about brackets before. Brackets is a way that math teachers just basically package stuff together. So it's like, oh, here's a big package of math stuff. Yay, what a great package, right? We've also seen that in algebra, brackets mean multiplication. So we're going to tie those two things together. A package with multiplication. So if you see this in a math equation, let's think about how that actually looks. 2 bracket x plus 5 equals 14. Okay, well what we should see is this is a package, right? So let me back up. So don't think of it as just a package. Okay? So just like anything else, we always kind of take care of the package, right? But what we have here is 2 packages, 2 times a package. So the way you want to think of this is you're multiplying that 2 by everything in the package. So when you open up the package, you're multiplying the 2 times the x, 2 times x. You're multiplying the 2 times the 5, 2 times 5. And anything else that's in the package. Well, that's all that's in the package. Well, 2 times x we write as 2x. That's how we write it, because we don't want to put a little time symbol in between. And we can't actually multiply it unless we know what x is. Now, 2 times 5 we can do. 2 times 5 is 10. And we now have essentially removed the brackets or opened the package. So this is now an important step. When you have brackets in your math equations in algebra, you want to get rid of the brackets first. Just get them out of the way. Okay? So it'll make your life easier. Once you get to here, then you can let your method take over. This actually has a name. It's called the distributive property. Okay? This is because you're distributing. It's like me passing out papers. If you guys were all inside of brackets, I'd give you all papers because I'm distributing it to everyone. Okay? Here's some other examples. 3x, 3 times 5, 3 times negative 2. It's the 3 times everything in brackets, 1 at a time. Here's another one. This is an x. X times 5, x times 4, x times 1. And everything gets distributed. It's like I'm passing out the x to everything in the brackets. It's like I'm passing out the 3 to everything in the brackets. But I'm using multiplication to do this. Okay? This is where it gets harder. You need to understand what the question is asking. Okay? You're going to get better at it through practice. Okay, so here is the final version of this method. This is the only real method you have to learn in this unit in terms of algebra, and it's this. Step 1, do your arithmetic first. If you can do arithmetic, do it. Step 2, remove the brackets. So this is the new step I'm moving in. That's now right at the beginning. Remove your brackets. Remove any values on the same side of the variable that are not connected to the variable by doing the opposite, and keeping balance by doing what one side you do to the other. Repeat step 3 if necessary until the variable is all alone, and then finally check it. Let's try it. Here's a problem. Step 1, any arithmetic? Nope, no arithmetic I can do. But step 2, remove the brackets. So that I can do. 2 times x, 2x. 2 times 4 is 8, and it's 2 times negative 4, so it's negative 8. Okay, I've done step 2. Step 3, remove values on the same side of the variable, not connected to the variable. So not connected to the variable is a -8. I'm going to get rid of the -8 with a +8. But I do it to both sides to keep balance. Now that the 8's gone, I rewrite this. So now you can see multiple steps. I'm at 2x equals 20. Now I need to go back, repeat step 3. I'm going to get rid of 2 times x by dividing by 2 both sides, and x is 10. Let's check it. 2 times 10 minus 4, which is 2 times 6. 2 times 6 is 12. And yeah, 12 equals 12. It checks. That's how you do it. Let's try another one, a more complicated one. Now this is the kind of problem that you can see this is now reaching the level very much like, hang on, let me go back, like this one from the grade 9 math exam. So it's very similar in some ways. Actually, it might even be harder. Okay? But let's go through the steps. Step 1, do any arithmetic first. So here I can do some arithmetic. I can do arithmetic on this side. I can go, oh, well, what's 400 plus 84? 484. What's 484 divided by 11? Oh, it's 44. So I just took all this and did it as arithmetic. Now I'm here. Okay? So my first step was to do the arithmetic. Now I'm going to get rid of the brackets. Well, 4 times x, 4x. 4 times 1, 4. Now I got rid of my brackets. Each time I'm making it a little bit easier. This is like any of you who've done any like carving. You're whittling away at the problem. Now I need to get rid of the stuff not attached to the variable. So I'm going to get rid of the +4 with a -4 on both sides to keep balance. So now I got this. 4x equals 40. Now I go back and do it again to get rid of the 4, but I divide by 4 because that means, 4x means 4 times x. So I'm doing the opposite, dividing, opposite of multiplication and division. But I do it to both sides to keep balance. The 4's cancel out. I have x equals, well, 40 divided by 4 is 10. And I've got a solution now. It took a while to get all the way down there. You don't want to rush through these problems. The bigger, the more challenging the problem, the more steps and writing it's going to take. If you shortcut that, chances of you getting a mistake is high. Take your time, write stuff down, and you're more likely to get it right. Let's check it. Well, I know this side, I already did this side. It gets all the way down to 44. But on this side, it's 4 times 10 plus 1, which is 11. And 4 times 11 is 44. And yeah, 44 equals 44. It worked. Okay? Obviously, teachers are going to make it harder. They're going to keep adding more arithmetic, more steps, more algebra. But the method stays the same. This method that I just showed you, this is the same method I teach my grade 9 math class. This isn't a special numeracy method. This is the method, the inverse operation that is taught to grade 9, grade 10. It's the same method. So you got to practice it to get good at it. Let me simplify it. Rather than all this writing, that's maybe too much for you to remember. Let's just break it down into something simpler. Do your arithmetic. Do your brackets. Do the opposite and keep balance. Isolate the variable and then check it. Let's just call it a bobic. That's a bobic right there. A bobic is going to help you solve your algebra. That's a weird way to remember it, but a bobic. Say it out loud. It'll help you remember. A bobic, a bobic, a bobic. Also known as the inverse operations method. Do your arithmetic, do your brackets, do the opposite, do the balance, isolate, and check. And you know what? If you forget to check, that may not kill you, just to forget it. So, you know what? If you forget your arithmetic, that may not kill you either. So really the core of the arithmetic is just Bobby, B-O-B-I. Bobby will help you get your done. All right, let's wrap up today. The new piece of language I taught you today was called the distributive property. It's how you deal with brackets. Solving equations now has these 5 steps, or you could simplify it to just a bobic, or even just Bobby, to remember it that way. Okay? Now, one last thing. Let's do this one. I'll do it for you. Okay? How to solve for x in this one. So, it's kind of tricky. How would we do this? Well, let me go through the steps. Step 1, arithmetic. Well, I can't do any arithmetic with this. I can't actually do any arithmetic on this side of the variable, or the equal sign, or this sign. because there's variable there. I can't do arithmetic with a variable. So I move to step 2. I need to get the variable by itself by getting rid of stuff not attached to the variable. Well, the 7's not attached, and this means divide by 7. What's the opposite of dividing? Multiply. Both sides by 7. What that means is the 7 goes away. Okay? So I have 2x minus 8 equals, well, what's 7 times 2? 14. Now I'm here. Now I repeat the process. I want to get rid of the variable by getting rid of stuff not attached to the variable. I'll get rid of that negative 8 by adding 8. And I get 2x equals, what's 8 plus 14? 22. Now what? I need to get rid of the 2. But this means 2 times x. I get rid of multiplication with its opposite, division, leaving me x by itself, and 22 divided by 2 is, which meant this was the right answer. That's from this year's grade 9 math exam. And you guys can see the method I taught you guys would actually work to get her solved.